Welcome to Word Problem Mania, Problem 2. Today we'll find two real numbers whose difference is 40 and whose product is a minimum. Go ahead and pause the video if you'd like to solve it yourself. Okay, let's begin. So it says find two real numbers whose difference is 40. So we'll call those two real numbers a and b. So a minus b is equal to 40. This includes tons of numbers like 1,000 and 40 and 1,000. Well, that makes 40. 1,000 and 960. Well, that makes 40. 42 minus 2. Well, that also makes 40. So there's tons of numbers. The second part says that a times b, so two numbers that satisfy this condition, condition 1, a times b is a minimum. So what we'll end up having to do to solve this problem is solving for one of the real numbers in the first equation and plugging that value into the second equation, and then using a little bit of calculus to determine the minimum in that relationship. So for the first one, we need to solve for one of the real numbers. Let's solve for a. So a is equal to 40 plus b. Now we will substitute this value into 2. So a times b must be a minimum. We're looking for the combination whose difference is 40 and whose product is the smallest possible while sustaining that first condition. Well, we have solved for a, so we're going to plug that value in for a here, which is 40 plus b. So 40 plus b is a. Now we have to multiply that by b, and I will now call this f of b, the function of one of the real numbers, which is directly related to the other real number, so it's wonderful. Simplifying this, we have b squared plus 40b. Alright, so this is a function of b, and this describes all the possible products of these two real numbers who satisfy this first condition. So in order to find when this product is a minimum, you can graph it and look for the minimum where the tangent line has a slope of 0, or you can find basically the tangent function, or f prime of b, and you can find when it equals 0. And then you can do a test to determine if it's a min or max, which in this problem it'll be obvious. So we'll take the derivative of f with respect to b, take the derivative of b squared, and you have 2b, and the derivative of 40b is 40. Now we need to find when f prime of b is equal to 0. So we'll substitute this value in here, the 0, and we'll solve for b. So 0 is equal to 2b plus 40. I'm going to flip this around, by the way, and first I'll subtract 40 from each side. So I have a negative 40 over here, so I have 2b equals negative 40. Multiply each side by 1/2 or divide by 2. Same thing. And you have b equals negative 20. So this is a point b which satisfies this condition, at least where m is equal to 0. So we can use this value and plug it into 1 in order to solve for a. So we have a minus 20, negative 20, is equal to 40. Well, a minus negative 20 is a plus 20, which is equal to 40. And subtracting 20 from each side, you have a is equal to 20. So find two real numbers whose difference is 40. A, 20 minus negative 20 is equal to 40. So 20 plus 20 is equal to 40, so that's true. Now and it is a difference. And if you consider the product of these two functions, if you look at a minus b equals 40, well, that can really go on till infinity. You could keep stacking larger and larger numbers on top of a and b, so there's no bound, so there's no max value. And if you look here, there's only 2 points, 2b plus 40. There's only one solution, and we know it is not a max, so it must be a min. So the solution to this problem is one of the numbers is 20, one of the real numbers, and the other real number is negative 20. Alright, that's it. Hope it helped.